Hello friend, this is the second module course Vibrational Analysis in ANSYS APDL. In this module, we will deal with vibrational problem that we are going to solve and how we are going to connect it or model the problem in ANSYS APDL. So we can do some basic hand calculation of the problem, and we can also do some lab test, and we will have two data, one from hand calculation, one from experimental setup. And the third way to solve this problem that we are going to use ANSYS. So we will have the physical problem. We have the inputs in terms of physical principles. We will have some assumptions. And ANSYS is itself a mathematical model. It's a program. So we will put those physical inputs with some certain assumption in the ANSYS tool, and we will do some post-processing, and we will solve the problem, and finally we will get the results involving some deformed shape or nodal solution. So we can just understand the basics of nodes and elements that we are going to be frequently use in this model. Node is a coordinate location in a space where the degrees of freedom are defined. The result of finite element analysis are usually given at the nodes. So we can see below, so this point is called node, but this whole rectangle, that is an element with 4 nodes. So this area, this rectangle is called element, but each point on this rectangle is called node. Element can be defined as a mathematical relation that defines how the degrees of freedom of node relate to the next. These elements can be lines. When we solve the problem of truss and beams, the elements that we use are 2D elements. We can use multiple 2D elements to create 3D plate or 3D element, solid element, bricks or tetrahedral. It also relates how the deflection creates stresses. So it depends what the element type we are using. On the basis of that, we can get the stress and the strain in the element. Preprocessor. So in preprocessor, we define the element type. We actually model the problem mathematically using ANSYS. So in that, we define element type, constant, the material properties, actual modeling of the body that we are going to analyze, and what are the types of element we are using to measure that. So these things are done in preprocessor. In solution, we define loads, boundaries condition, and then we solve. In general post-processor, we read the results and we get the results in the format or form as we want. Like we can get the result in table form, we can get the result in graphical form, we can get the result in the form, shape and size. Body. Summary of the model. By the time we should be able to know how do we model the practical problem in ANSYS APDL, we should also be able to know the different steps that we follow while solving a vibrational problem in ANSYS APDL. The next module, we will learn about problem steps, how we are going to solve that problem in